Now that we have done the analysis of the band brake, we have the two equations which are there in the band brake. We'll just revisit that. The first equation is that T1 minus T2 into R is equal to C, and the second equation is T1 by T2 is equal to e to the power mu theta. Now we'll use these two equations to solve this question on band brakes. So the first thing that we'll do is that we'll say that the tension in this string is T1 and the tension in this string is T2. Is there a way by which we can find out this T1 for certain? Yes, we can. What we can do is we can make an isolation volume around this mass and we can cut it out, and the FBD that we'll get is this mass M with two forces. There's a downward force of mg, there's an upward force of T1. So without even knowing anything about band brakes, what we can tell is that T1 is equal to mg, which in our case is equal to 10 kilograms into 10 meter per second square, which is 100 Newton. Now the next thing that we know is that the pulley is about to slip. So seeing this, we know that when it is almost slipping, T1 by T2 is equal to e to the power mu theta. So over here, what we can tell is that T1 by T2 is equal to e to the power mu theta. The theta is 90 degrees, which is also pi by 2 radians, and in this case theta we'll have to take it as radians, and mu is 0.5, so this ratio is e to the power pi by 4, which is equal to 2.193. So T2 is equal to T1 by 2.193, which is equal to 49.595 newtons. Now simply from the condition that the pulley is in equilibrium, we can say that C is equal to T1 minus T2 into R. We know the value of T1, we know the value of T2, and we know the value of R. So all we need to do now is put these values in to find out that C is 5.04 Newton meter. Now this is the maximum amount of torque that can be applied to this pulley, and this pulley will still remain stationary. Do solve this short quiz, as it will be a useful practice of the concepts learnt in the chapter on band brake.